Water flows out from a large tank of cross-sectional area AT is equal to 1 meter square. So the cross-sectional area of the tank is 1 meter square. Through a small hole, rounded orifice of cross-sectional area A0 is 1 centimeter square, located at y is equal to 0. Initially the water level is measured from y is equal to 0 is 1 meter. So the height h is equal to 1 meter is the initial height of the water level. Now we have to consider the acceleration due to gravity as 9.8 meter per second square. Now neglecting any losses, the time taken by the water in the tank to reach the level of y is equal to h by 4. Now if from y from h it reduces to y is equal to h by 4, we have to calculate that how much time it will take. Now from the conservation of mass, we have to understand that here whatever is the amount of water going out from this orifice must be equal to the rate of change of the water in this tank, right? So we can write this as change of mass of water. Let's write m inside the tank, t, the subscript t represent the water present in the tank. Okay, with respect to time, it is changing with respect to time, should be equal to mass flow rate, initial mass flow rate minus the final mass flow rate of water in the tank, right? Now here in the problem, initially there wasn't any mass flowing out of this tank, so this quantity will be equal to 0. And we have to calculate whatever the mass is going out of this tank and the height it should reach h by 4, how much time it will take. So from here, from this equation, we are getting a differential equation, and that is equal to minus m naught dot should be equal to change of mass inside the tank with respect to time. Now we know the mass flow rate here, mass flow rate of water in this case. This is m dot can be written as rho, that is the density, into area multiplied by the velocity with which it is moving out. So for this problem we can write, so minus rho density of water multiplied by, it is going through the orifice, right? So we will consider this area, this mass flow is going through the orifice A0 multiplied by the velocity, right? So velocity is given by under root of 2gh. This we can obtain from Newton's equation of motion, and this is equal to dm upon dt. Also this mt, that is mass in the tank, is given by the volume of the tank, right? Not the tank, volume of the water, that is initial volume of water. What is it? Area multiplied by the height, that will give the volume. So volume into density will give the mass. So let's write AT, that is cross-sectional area of tank, into initial height, that is h, into the density of water. So this will be mt. Now if we substitute it here in this equation, we can write the differential equation as dt is equal to minus AT upon A. We are taking all these quantity to the right hand side, so we can write AT upon A 1 by under root of 2g, and h we can write it like this, dh upon square root of h. Okay, so this h, let's write it capital H here. Okay, if we integrate this equation, we can integrate it from initial time. Let's write ti for initial time and tf for final time, and here it is initial height hi to final height hf. Okay, so if we integrate it, so here in the left hand side we'll have tf minus ti, that is nothing but time. So let's write t for it, time taken, and here let's write the constant quantities outside, a under root of this we can write integral initial height to final height dh upon square root of h, and if we integrate this equation we get t by a to 1 by root 2g multiplied by, after this integration and if we substitute the value, the limit, so we get 2 times of square root of HF minus square root of initial height. Okay, so this is the time taken. This is how we calculate time taken for the water to reach some final height HF. So let's substitute all this value. So time taken T will be equal to negative of AT is given to us in the problem, that is 1 meter square, and A naught, this is A naught actually, right? The orifice cross sectional area, A naught. It's given in the problem, A naught. Okay. So this value is 1 centimeter square, that is 10 to the power of minus 4 meters square, into 1 upon square root of 2 into 9.81 into 2 into square root of HF. Final height is given as how much? Let's see here. So the initial height is 1 meter and the final height h by 4, that is 1 by 4 meter, right? So let's write here, final height is 1 by 4 minus the initial height 1 meter. Okay, if we do this calculation, we get T is equal to 2258.8 seconds. Now let's go back to the problem and fill in the blank. So the time taken by water in the tank to reach the level h by 4, that is somewhere around here, h by 4, this is 2258.8 seconds, because we have to calculate in second and round off to 1 decimal place. So this is our final answer. Now to solve these type of problems, you can refer to the NPTEL course lecture number 7, flow measurement on industrial automation and control by Professor S. Mukhopadhyay of the Department of Electrical Engineering at IIT Kharagpur.